Imagine an AI that doesn't just follow your commands, but thinks for itself, that reasons, plans, and learns on its own, like a teammate in a video game. An AI that can not only act in virtual worlds, but also reflect on its actions and improve over time. That's not science fiction anymore. That's SIMA 2, Google DeepMind's newest generalist agent. Powered by the Gemini model, SIMA 2 represents a major leap in artificial intelligence. It's not just a better version of its predecessor. It's a fundamentally more capable system. It doesn't just do what you ask. It understands. It doesn't just react, it reasons. And perhaps most strikingly, it teaches itself. In this video, we'll unpack how SIMA 2 works, why it matters for the future of AI and robotics, and what its rise signals for economics, innovation, and our shared future. So let's dive in. At its core, SIMA 2, which stands for Scalable Instructable Multi-World Agent, is a research agent built to operate inside 3D virtual worlds. DeepMind designed it to receive what it sees on screen, visual input from a game-like environment, and accept high-level human goals, like build a shelter or go to the Red House. Then, SIMA 2 breaks down those goals, reasons about them, decides what to do step by step, and controls its avatar via a virtual keyboard and mouse, just like a human would. That might sound like the first SIMA agent, but SIMA 2 goes a lot further. One of the biggest advances is that it's powered by Gemini, Google's large multimodal language model. Integrating Gemini gives SIMA two powerful reasoning abilities. It can interpret abstract goals, ask clarifying questions, explain its plan, and even talk to users as a companion rather than a puppet. Why is this shift so important? Because it moves the AI from being a command follower to something like a collaborator. According to DeepMind, interacting with SIMA 2 feels less like giving it commands and more like collaborating with a companion who can reason about the task at hand. And there's more. SIMA 2 can work in games it has never seen before. DeepMind tested it in environments like MineDojo, a Minecraft-style open world, and Aska, a Viking survival game. Even in these unfamiliar worlds, SIMA 2 successfully carries out long and complex tasks. That generalization, the ability to transfer what it has learned to new domains, is a huge step toward artificial general intelligence, AGI. Another area where SIMA 2 shines is self-improvement. Unlike SIMA 1, which relied heavily on human gameplay data, SIMA 2 creates its own training data. Here's how. Once placed in a new environment, one Gemini model proposes tasks, while a separate reward model scores how well SIMA 2 performs. Successful trials are stored and used to train the next generation of the agent. Over time, the agent learns from its own mistakes, like a human learning via trial and error, but without a constant stream of human-labeled feedback. This feedback loop is a form of reinforcement learning from AI-generated feedback, cutting down on the need for expensive human annotation. DeepMind also tested SIMA 2 in completely novel, procedurally generated worlds, using another of its research tools, Genie 3, a world model that can generate realistic 3D environments based on text or images. SIMA 2 navigated these generated worlds, identified objects like trees, benches, and butterflies, and took meaningful actions, despite never having seen that world before. That means it's not just memorizing patterns from existing games, it's reasoning about the structure of the world itself. So what does all this mean? SIMA 2 confirms something DeepMind sees as vital: that an AI trained for broad competency, using data from many kinds of virtual worlds and powered by a reasoning backbone like Gemini, can unify the capabilities of many specialized systems into a single generalist agent. In other words, instead of needing different AIs for every game or environment, you could potentially have one AI that understands and acts across many. This unification is not just theoretical. DeepMind argues that the skills SIMA 2 is mastering, navigation, tool use, goal-directed planning, are the same building blocks needed for embodied intelligence in the physical world. In their vision, SIMA 2 is more than a gaming AI. It's a stepping stone toward general-purpose robots. But what about performance? The jump from SIMA 1 to SIMA 2 is no small improvement. In publicly reported tests, SIMA 1 had about a 31% success rate when completing complex tasks, according to DeepMind. SIMA 2, by contrast, has roughly doubled that performance in its internal benchmarks. That's a dramatic leap in capability. Let me illustrate with an example. DeepMind showed, in No Man's Sky, SIMA 2 saw a rocky planet surface, identified a distress beacon, understood what that meant, and planned to investigate it. In another case, you might tell it, go to the house that's the color of a ripe tomato. SIMA. 2 reasons. Ripe tomatoes are red, so it should look for a red house, and then it does that. It even understands emoji instructions. If you send, it knows to chop a tree. These are not trivial capabilities. They show true semantic reasoning. Of course, the technology isn't perfect yet. DeepMind acknowledges that SIMA 2 has its limitations. It struggles with very long, multi-step tasks that require extended memory. Its context window remains limited, which constrains how much of its past it can use to reason about future steps. And while it controls via a virtual keyboard and mouse, it doesn't yet handle low-level physical actions, like managing robotic joints or wheels. But the researchers are clear that these are not fatal flaws. They are current challenges, part of the iterative path toward more capable embodied systems. Let's pause for a second and ask, why should any of this matter for finance or economics, or for the real-world value of such an agent? Because SIMA 2 isn't just a gaming experiment. It demonstrates a scalable, self-improving architecture that could one day translate into physical robots that reason, adapt, and learn. Robots that don't just follow scripts, but set their own sub-goals, learn from mistakes, and work alongside humans. That opens up huge economic possibilities. AI agents that maintain warehouses, assist in homes, navigate complex terrain, or even act as intelligent robotic assistants in industries. The capital investment to build such agents may pay off in dramatic productivity gains. Moreover, SIMA 2's self-generated feedback loop reduces reliance on expensive human-labeled data, which could dramatically lower the cost of training future agents. Think of it this way. Instead of needing armies of human demonstrators to show it every task, the system can bootstrap itself. That's a breakthrough in scaling, and from an innovation standpoint, integrating reasoning via Gemini with action in virtual worlds is exactly the kind of unified architecture that many researchers believe is critical for reaching general intelligence. DeepMind themselves frame SIMA 2 as a milestone toward AGI. If this vision is realized, it could reshape industries, influence labor markets, and even redefine how we think about automation and creativity. Now that we understand what SIMA 2 is, let's dive into how it actually learns. This is where the Gemini model really shows its power. Think of Gemini as the agent's brain. It's not just memorizing actions, it's reasoning through them. It can understand abstract concepts, plan multi-step strategies, and even evaluate outcomes before acting. In other words, SIMA 2 doesn't just see the world, it interprets it. SIMA 2's training process is fascinating because it blends human demonstrations, reinforcement learning, and AI-generated feedback. The human demonstrations provide an initial understanding of tasks. Then, the agent is released into procedurally generated worlds where it performs actions and receives scores from an internal reward model. This loop is repeated millions of times. Successful behaviors are reinforced, mistakes are corrected, and the agent gradually improves. Unlike earlier systems, SIMA 2 can generate its own learning signals, reducing the need for costly human input. Imagine a child learning not just from teachers, but from their own trial-and-error adventures. That's SIMA 2 in action. But the real innovation isn't just in the training, it's in generalization. DeepMind reports that SIMA 2 can handle novel tasks that it has never encountered. For instance, when presented with a new virtual environment, the agent identifies key objects, infers relationships, and makes plans, even without prior exposure. This ability to transfer knowledge is a hallmark of generalist AI. It's one thing for an AI to master chess or Go. It's another for it to navigate a completely new environment and accomplish goals it's never seen before. That's a level of flexibility previously unheard of. Let's put this into a real-world perspective. Picture a warehouse where robots need to sort packages. Traditional robots follow strict pre-programmed paths, change the layout, and they falter. SIMA 2, however, could learn the new layout, adapt its actions, and optimize workflows, all autonomously. The economic implications are enormous. Fewer bottlenecks, lower labor costs, and faster scaling of automated operations. Another exciting development is SIMA 2's potential for embodied AI. While it currently operates in virtual worlds, its underlying architecture is compatible with robotics. Imagine giving SIMA 2 a physical body, a robot with arms, cameras, and sensors. Because SIMA 2 already understands spatial reasoning, planning, and goal-directed behavior in 3D worlds, it could transfer those skills into the physical world. That's the Holy Grail: robots that can reason and act autonomously across tasks without constant human guidance. Now, consider the broader societal impact. SIMA 2 represents a step toward AGI, but with that comes both promise and caution. On one hand, you have productivity boosts, scientific discoveries accelerated by intelligent agents, and new forms of human-machine collaboration. On the other hand, there are ethical and economic questions. How do we govern AI that can act autonomously? How do we prevent misuse? And what happens to jobs as AI agents become capable of handling complex tasks once reserved for humans? There's also the question of trust and transparency. SIMA 2 can explain its plans in natural language, which is a game changer. Users can ask, "Why did you choose to do that?" and receive a logical explanation. This level of interpretability is critical for adoption in industries where accountability matters, like healthcare, logistics, or finance. AI that can justify its decisions is far more likely to be integrated safely and effectively. Let's also touch on the economic angle. AI like SIMA 2 could drive the next wave of automation, not just repetitive tasks, but creative, strategic, and technical work. Companies investing in AI generalists could see unprecedented gains in efficiency. For investors, this signals a potential reallocation of capital. Firms that adopt AI early may dominate markets, while laggards could be left behind. It's a shift reminiscent of the Industrial Revolution, but in the digital and cognitive domains. SIMA 2 also highlights a new model for scalable AI development. By combining multi-world training, AI-generated feedback, and reasoning-powered decision-making, DeepMind demonstrates that we can build agents capable of learning efficiently at scale. That's key for industries that require rapid adaptation: finance, energy, supply chain logistics, and even defense. And the story doesn't stop there. SIMA 2 is just the first of a new generation of agents. DeepMind envisions iterations where agents become increasingly capable of long-term planning, multi-agent collaboration, and physical interaction. In other words, SIMA 2 is a foundation, not a final product. What we're witnessing is a glimpse of the AI ecosystem of the near future, a world where intelligent agents operate across digital and physical spaces, augmenting human capabilities in unprecedented ways. Finally, SIMA 2 also raises philosophical questions. If an AI can plan, reason, and self-improve, what does that mean for human uniqueness? And if it can learn across tasks, how do we define its intelligence? These aren't just technical questions. They touch on ethics, economics, and society as a whole. So, what does SIMA 2 really mean for the world beyond video games and research labs? Let's break it down. First, the robotics revolution is closer than you think. SIMA 2's ability to reason, plan, and learn in 3D virtual worlds is directly transferable to physical robots. Picture a warehouse or construction site where robots not only follow instructions, but adapt to changes on the fly, collaborate with humans, and even optimize their own workflows. That's a seismic shift for productivity and efficiency. Industries that adopt this early could see massive advantages, while those that lag risk falling behind. Second, economic implications are massive. Agents like SIMA 2 reduce reliance on human labor for repetitive and complex tasks. They can cut costs, accelerate innovation, and scale operations rapidly. But there's also disruption. Jobs that once required human reasoning or planning could be automated. Governments, businesses, and educators will need to rethink workforce strategy, training, and social safety nets to address these shifts. Then, there's the investment angle. Companies integrating AI generalists into operations could outperform competitors dramatically. Investors should watch sectors like logistics, robotics, industrial automation, and AI software because the potential ROI from early adoption is enormous. SIMA 2 demonstrates that AI is no longer just a research curiosity. It's a commercially viable, scalable technology. SIMA 2 also sets a new standard for AI design. Combining multi-world data, AI-generated feedback, and advanced reasoning in one generalist agent could become the blueprint for the next generation of AI. This approach might eventually give rise to systems capable of more strategic thinking, creativity, and decision-making, tasks previously thought to require human intelligence. But we can't ignore the ethical and societal dimensions. Autonomous, self-improving agents raise questions about accountability, misuse, and control. If an AI can make decisions and act independently, who is responsible for the outcomes? DeepMind is taking steps toward transparency, letting SIMA 2 explain its reasoning. But the broader world will need clear policies, governance frameworks, and oversight to manage these technologies safely. From a technological perspective, SIMA 2 also highlights a path toward AGI. It's not just about mastering a single game or task. It's about generalization, adaptability, and learning across domains. Exactly what a truly intelligent agent would need. Every step SIMA 2 takes toward reasoning, problem-solving, and self-improvement is a step closer to AI systems that could think across disciplines, handle novel challenges, and collaborate with humans in ways we haven't seen before. In short, SIMA 2 is more than a game-playing agent. It's a research milestone, an economic catalyst, and a glimpse into the AI-driven future. It demonstrates how integrating reasoning, multi-world experience, and autonomous learning can produce an agent capable of tackling complex, dynamic environments, a capability with real-world applications from robotics to industry and beyond. As we move forward, the challenge won't just be building smarter AI, it will be using it responsibly. SIMA 2 shows what's possible when we combine ambition, innovation, and rigorous research. The question is, are we ready to harness its potential safely and to ensure these technologies serve society as a whole? So, what's the takeaway? SIMA 2 is a leap toward autonomous, generalist AI, a system that can learn, reason, and adapt. It has economic, industrial, and societal implications that could reshape how we work, invest, and innovate. And it represents a foundation for future AI systems that could operate seamlessly across both digital and physical worlds. If you found this deep dive into SIMA 2 fascinating, make sure to like this video, leave a comment with your thoughts, and subscribe for more insights on cutting-edge AI and economic trends. And don't forget to check out our other videos exploring the future of AI, robotics, and financial innovation, because the world of technology is moving fast, and you don't want to be left behind. SIMA 2 isn't just the next step in AI. It might just be the start of a revolution.